Good morning. In previous section, we discussed regarding how to solve three-hinged parabolic arches. Now, in this particular section, we'll move on to problems. So, please observe the given problem. It is very important problem from the examination point of view. So, in this particular problem, first focus on what is the span of the given parabolic arch. What are the different loads are given. So, in which a three-hinged parabolic symmetrical arch. The given problem is symmetrical parabolic arch has a span of 30 meter. So, a symmetrical three-hinge. So, one point A, second point B and C. This is a symmetrical parabolic arch A, B, C. Symmetrical parabolic arch. So, has a span of 30 meter. So, the span between A and B is 30 meter. L equal given by 30 meter. So, this is the span. Span is given as 30 meter and a central rise of 6 meter. So, central rise of 6 meter. So, exactly 15 meter crown. So, central rise H equals 15 meter, not 15 meter, central rise of 6 meter, exactly 15 meter, the central rise of 6 meter. The arch has to carry a UDL, uniformly distributed load of 30 kilonewton per meter over left half portion. So if you consider left half portion, exactly left half portion, this arch consisting of uniformly distributed load of 30 kilonewton per meter. Uniformly distributed load of 30 kilonewton per meter and a concentrated load of 60 kilonewton at 9 meter. Please observe this concentrated load of 60 kilonewton at 9 meter from the right hand support. If it's a left support, this is the right hand support. From right hand support, we are having concentrated load of 60 kilonewton from 9 meter. So, say here it's having 60 kilonewton point load and the distance from right support, is given as 9 meter. 9 meter. This is a given data. So, that is given in sentence formation. We have just taken a schematics diagram. Now, what we have to compute using this symmetrical three-hinged parabolic arch, we have to compute bending moment. Is asking to compute bending moment of the arch and also normal thrust and radial shear, NT and RS. Normal thrust and radial shear at 9 meter from the left hand support. So, it's a right hand support and left hand support. From left hand support, this is right hand, this is left hand. From left hand, he is asking to compute from 9 meter radial shear and normal thrust. So, the ultimate aim of the problem is to determine bending moment, radial shear and normal thrust 9 meter from the left hand support. So, we will move on to step by step, as we know that the step 1 is determination of external reaction. Determination of external support reaction. So, what are external support reaction? Please observe over here. Here hinge support, we are having VA and HA. Here we are having VB and HB. Initially assume all positive sign convention. Later on it can change depending on whatever relevant values we are getting. So here at A hinge VA HA, at B VB HB. So in first step determine external support reaction. Matlab we have to determine VA HA VB HB. Because of this symmetrical parabolic arch, HA value equal HB value, that is H value. We know that. So first for this apply equations of statics. What is equation of static? Sigma Fy equals 0. What is the general sign convention? All upward forces are positive and downward forces are negative. What we are getting? Plus VA, and this load is acting in downward direction, so uniformly distributed load. Convert this UDL into point load. So minus 30 into 15, because it's running over a exact left half portion, that is 15 meter. Next, this is minus 60 plus VB equals 0. Now just compute what is the value of VA plus VB. You are getting 30 into 15 plus 60. So what is the value of VA plus VB? What is the value of VA plus VB? 30 into 15 plus 60. How much?
Sir, VB is equals to?
VA plus VB.
Okay.
VA plus VB equals?
500. Sir.
500. Okay. 450 plus 60. It seems 510?
Yes, sir, 510.
Yes.
510 kilonewtons. Sir.
510. Take this as equation number 1. 510. Equation number 1. Now, apply sigma Fx equals 0. Sigma Fx equal 0. What are horizontal forces we are having? HA and HB. Therefore, you are getting HA plus HB equals 0. Therefore, HA equals minus HB. HA equals minus HB. Take this as equation number 2. HA plus HB plus HA, because for this, what is the sign convention we are assuming? Horizontal right side forces are positive and left side forces are negative. Therefore, plus HA plus HB equals 0. Finally, we are getting HA equals minus HB. That is H. So, how to determine that H? Generally, we are having this crown portion. With respect to crown, take a moment, left portion or right portion, any one portion. So, we are getting H value. Now, in this problem, I am taking sigma moment at C equals 0 on RHS, right hand side. Only I am considering right hand side. If you consider this right hand side, what we are getting? This VB moving in this direction, rotating in anti-clockwise direction. Therefore, minus VB into what is the perpendicular distance? 15 meters. Minus VB into 15. Next, this HB. HB is also rotating in anti-clockwise direction. Minus HB into what is the perpendicular distance? For HB, 6 meter is the perpendicular distance. Into 6. And the 60 rotating in clockwise direction. We know that this is 15 meter. 15 minus 9. What is the value? 15 minus 9. The remaining is 6 meter. Therefore, it is rotating in clockwise direction. Therefore, plus 60 into 6, which is equals 0. Please observe here, we are getting VB, HB, 60. Only 3 forces into perpendicular distance. For this VB, it is rotating in anti-clockwise direction. This HB is also rotating in anti-clockwise direction, but the 60 rotate in clockwise direction. Finally, we know the VB value. We don't know the VB value, right? So we take this as equation number 3. Equation number 3. Next, we take sigma moment at A equals 0. Sigma moment at A equals 0. If you take sigma moment at A equals 0, we are getting 30 into 15 into 15 by 2 clockwise. That's why positive. 30 into 15 into 15 by 2. Next, the 60 into 15 plus 6 plus 60 into 15 plus 6 is 21. Next, this HA, HB both are 0 because they are moving in same line of action, won't produce any kind of moment. Minus VB into minus VB into 30, which is equals 0. Now just reduce this particular thing. We are getting the value of VB. That is 30 into 15 into 15 by 2 is 7.5 plus 60 into 21, which is equal 30 VB. Please compute the value of VB. Put the value of VB. What is value of VB?
VB is equals to 154.5 kilonewton, sir.
154.5 kilonewton. Now we got VB value. Now substitute this VB value to equation number 1. We are getting VA value. So from equation number 1, we are getting VA equals 510 minus 154.5. So what is VA value?
355.5 kilonewton, sir.
355.5
kilonewton.
kilonewton. So we are getting VA value and VB value. Now substitute this VB value in equation number 3. We are getting HB value. Substitute this VB value in equation number 3. Substitute this VB value in equation number 3. From equation number 3, please compute HB value. We know that VB, therefore minus 154.5 into 15 minus HB into 6 plus 360 equals 0. So compute HB value. What is HB value?
326.25 kilonewton, sir.
326.25
kilonewton, sir.
25 kilonewton. It is just positive or negative?
Positive.
Positive. So now we got HB value. So now we know that HA equals minus HB. HA equals minus HB. Therefore we know that HA equals minus HB, that is 326.25 kilonewton. So what we have to do, we got minus HB, therefore we just reverse the direction of HB. See, because we got minus HB, so plus HA equal minus HB. So now the equations of equilibrium condition will satisfy. So this is the first step, determination of external support reactions using equations of statics. What we did, first we applied sigma Fy equals 0 plus VA minus 30 into 15 minus 60 plus VB equals 0. So we got an equation, VA plus VB equal 510. Next we applied sigma Fx equals 0. If you apply sigma Fx equals 0, we are having two horizontal forces. There is no inclined loading on this particular arch. Therefore plus HA. Initially we assumed positive, that's why plus HB equals 0. So HA equal minus HB we got, that's why we reversed the direction. We got HA equal minus HB, that's why we reversed the direction. Next we have taken at crown point moment, because we have to determine the horizontal reaction. When you are taking at crown point, please consider whether left hand side or right hand side. In this particular case, I have taken right hand side. I have computed, we got an equation because VB is the unknown. Next, we have taken another equilibrium condition, that is sigma MA equals 0. On that condition, we have got VB value easily. Once we got VB value, from equation number 1 and 3, we are getting VA and HB value. So this is the first step. Then second step. What is the second step? We know that we are doing parabolic arch. The ultimate aim of the problem is to determine the bending moment first. So that's why first initially consider equation of parabola. So what is equation of parabola? Y equal 4hx by L square into L minus x. So equation of parabola. So now we are having two things. One is h. H is central rise. And x, this is the variable. Whatever the distance we want, we can take that particular value in x coordinate direction. So in this particular case, 4 into 6 into x divided by, what is L? L is the length of the arch. Length of the arch is 30 meter. Therefore, this is 30 square. 30 square into 30 minus x. If you simplify this equation, we are getting y value. So what is y value?
Y is equals to
Y equals
0.8x
0.8x
minus
minus
0.027
0.27
x square.
x square. See, this is the equation of parabola. 4 into 6 by 30 square into 30, we are getting 0.8x. Similarly, whatever we just multiply with x into x square, we are getting the value. This is called equation of parabola or rise equation. This is rise equation. Now differentiate this equation. Say this is equation number 4. Differentiate equation 4. We are getting slope equation. dy by dx, which is equal tan theta, which is 0.8. X differentiation of x is 1, therefore 0.8 minus 0.027 into 2x. So we are getting
0.054x.
0.054x. So we got tan theta, that is slope, that is 0.8 minus 0.054x. Say equation number 5. This is the slope equation, where y is rise equation and tan theta is slope equation. Once we got this rise and slope equation, then we can easily determine the values of bending moment. So when you are coming to bending moment diagram, at hinges, moment at A, moment at C, moment at B, we know that at moment at hinges is 0. So then what we have to compute? You take this as E, we have to compute moment at E, and also there is a loading UDL. So we have to compute maximum moment between AC and maximum moment between CB. We know that maximum moment between CB under load, that is under point load, that is E. But where exactly in between AC? Generally UDL, the maximum moment under exactly half of this span. So we have to determine this maximum value between AC, bending moment, and CB. So next step, that is third step, that is BMD. So we know that moment at A, moment at B, and moment at C equals 0. Why? Because these are hinges. Therefore, moment at A, B, and C is 0. Next, compute the moment at E. Now between you can take AC first, next CB, no problem. So between A and C, we are having hinge, right? And there is a UDL. So 30 kilonewton per meter, exactly at 15 meter. And also we are having vertical reaction VA and HA. What is VA? VA value is, we have determined 355.5. What is the value of H? That is HA equal HB, 326.25. 326.25 kilonewton. So exactly at center. So exactly at center. Compute the value of maximum moment between A and C. Compute the value of maximum moment between A and C. Maximum moment between A and C. How to determine M max between A and C? You just take this as X and Y. So the section MXX, I am taking this section as MXX. Then we are getting, see, I am taking exactly half of the section. So MXX, therefore 355.5 into X, 355.5 into X, this is clockwise, and this H minus 326.25 into Y. This is the rise. I don't know this value, that's why this is Y. And minus this UDL. anti-clockwise. Therefore 30 into x by 2. See, please observe carefully. So I have considered AC portion exactly half, that is 15 meter span, but I want to compute the maximum moment. When you are computing maximum moment, so this anti-clockwise, I have taken this section xx, the horizontal distance I have considered as x and vertical distance I have considered as y. So minus 326.25 into y, minus 355.5 into x, and 30 into x by 2. But what is the value of x and y? The value of x equal 7.5 meter, that is 15 by 2. That is 15 by 2 maximum. The bending moment is maximum under load, exactly half of the span in the case of UDL. Therefore substitute x value here and y. What is y? Y value, I know that this is the equation, 0.8x minus 0.027x square. I know x value. So now mxx will become, mxx is the moment between A and C, will become 355.5 into 7.5 minus 326.25 into y. What is y? That is 0.8 into x. X is 7.5. X is 7.5. X is 7.5 minus 0.027 into x square. 0.027 into x square, that is 7.5 square, minus 30 into x by 2. 30 into 7.5 into 7.5 by 2. So simplify this equation. You are getting moment between A and C, that is mxx. Is the value of mxx?
360.5 kilonewton per meter, sir.
360.5
5
kilonewton meter. Kilonewton meter. This is the moment between AC. Moment between AC. Once we got moment between AC, in next step we have to compute moment between this section CB. Moment between CD. For this, it's very easily computable. Moment at E. Moment at E. Moment at E equals, this is reverse anti-clockwise direction, VB into 9, and this is clockwise, plus HB into Y, that is YE. So only these two forces will come. YE means this is the equation at x equal 9 meters. Therefore ME equals, what is the value of VB? What is the value of VB we computed? VB is 154.5. 154.5 into 9 plus HB. But HB value is minus 326.25. Therefore minus 326.25 into YE. We know Y equation 0.8x. But what is x? Here x is 9 meter. It's a x distance. Into 9 minus 0.027 into 9 square. If you compute, you are getting moment at E. If you just solve this particular thing, you are getting ME. What is the value of ME?
minus 955.
Minus 955.11 kilonewton meter. See, we got ME value and maximum XX. At section XX I have considered, so I got MXX. Now the bending moment diagram can easily plot using those values. How to plot bending moment diagram for 3-hinged parabolic arch? It's a very simple thing. Just first take an arch. We know that moment at A, moment at B and moment at C, all the values are 0. Moment at A is 0, moment at B is 0 and moment at C is also 0. In between AC we are having section XX In between CB we are having point E. What is MXX? MXX we got plus 360. So positive value represent above the arch. That is 360.5 kilonewton meter. In between CE, that is E is minus 955. So it is represent below the baseline of arch. 955.11. Now this is UDL. That's why what is the variation? Parabolic. The variation is parabolic. The variation is parabolic. Why? Because UDL. Because of UDL, the bending moment variation is parabolic. Next, this is linear. Why? Because of point load. Because of point load. This is linear. So this is negative and this is positive. Just read it. This is the bending moment diagram of the given arch. Next we move on to the last section. In last section what I am asking? I am asking to compute normal thrust as well as radial shear from 9 meter. This is very important. From 9 meter. 9 meter left hand side. Therefore please consider the arch from 9 meter left hand end. 30 kilonewton per meter, only 9 meter. Consider only 9 meter. I know the value of VA and H. What is the value of VA? What is the value of VA and H?
VA is 355.5.
355.5. What is the value of H?
326.25.
326.25
kilonewton, sir.
kilonewton. Okay. And this is you take Y value. Okay. But the thing is 9 meter distance. So we know the equation for normal thrust and radial shear. What is the equation for normal thrust?
H cos theta plus V sin theta, sir.
H cos theta
Plus V sin theta.
V sin theta. What is the equation for radial shear?
H sin theta
H sin theta
minus V cos theta.
V cos theta. All of you just observe over here. We want H and we want theta and we want V to solve normal thrust and radial shear. We know that H value is 326.25 kilonewton, and we don't know the value of theta, but we know the equation. Tan theta equals, we know the equation, tan theta equals 0.8 minus 0.054x. At what distance we have to compute the radial shear and normal thrust? At x equal 9 meter. At x equal 9 meter. At x equal 9 meter. Substitute in this equation, we are getting theta value. Theta equal tan inverse of some value. So what is that value theta?
Theta is equals to 17.43 degrees.
17.43
degrees.
degrees. Theta value we got 17.43 degree. We got H value, we got theta value. We require shear force. V is the shear force at 9 meter. Shear force is very simple. Just V equal plus 355.5 and minus 30 into 9. You just reduce this into point load. You are getting 30 into 9. Plus 355 minus 30 into 9. So what is the V value?
85.5 kilonewton, sir.
85.5 kilonewton. See, just observe here. We got H value, theta value, V value. Now substitute these values in this equation. We are getting normal thrust and radial shear required at 9 meter from left support. Right? Yes. Please substitute and tell me the answers. What is the value of normal thrust? And what is the value of radial shear?
Normal thrust 336.88 kilonewton, sir.
88 kilonewton, and radial shear
is 16 point. Sorry. 16.15 kilonewton, sir.
15 kilonewton. See. So this is the very simple problem. In first step we determined external support reactions. In second step we determined required rise equation and slope equation. In third step we determined bending moment diagram. In bending moment diagram, we know that at hinges the moment is 0. We determine the maximum moment under loads. In last step, we determine normal thrust and radial shear. Please follow these steps and solve more problem. We are giving assignments. Please try to solve using these steps. Okay? Thank you. Thank you very much.